So we're in chapter 8.2, which is conducting a hypothesis test involving a population proportion. And this is where we're going to use the calculator a bit to demonstrate how to do this. There are 4 steps in hypothesis testing. The first being to hypothesize or to state your hypothesis about the population parameter. Okay. Remember that when you're stating a hypothesis, it's for the population parameter, never for the sample statistic. Second, prepare a significance level or state a significance level. Choose an appropriate test statistics, state and check conditions required for future computations, and state any assumptions that must be made. The third step of the process is to compute and compare. Compute the observed values of the test statistic and compare it with what the null hypothesis said you would get. Find the p-value in order to measure your level of surprise. And finally, interpret. Decide whether to reject or accept or do not reject the null hypothesis. There are 4 conditions that must be met before you perform a hypothesis test. 2 of them are generally inferred from the problem. That is random sample and independence. Random sample is that, the sample that's taken is randomly drawn from the population, and independence is that each observation has no influence on the other. Those 2 are inferred from the problem. The second condition that must be met here is the large sample size, where the sample size times the probability of the null hypothesis must be greater than 10, and then the sample size times 1 minus the null hypothesis must also be greater than 10. This condition must be met, and then the condition that the population is at least 10 times bigger than the sample size must also be met. So 4 conditions that must be met before you can use a hypothesis test. Okay. Now, for all of the problems that we do, the condition will be met. But I just want to make sure that we are aware that we're supposed to check the condition. Here's an example. In 2009, it was estimated that 63% of Americans supported the death penalty. In 2014, a Rasmussen poll found that in a random sample, 943 Americans, 538 supported the death penalty. Question: do we have evidence that support the death penalty has declined among Americans since 2009? So consider that 63% and declined. Hypothesize that the null hypothesis, P is equal to 63.63, support has not changed. That's our null hypothesis. And because it's declined, we're taking less than 63 or less than 0.63 as the alternative hypothesis. Now, the sample based on the problem is random and independent, okay? That is inferred from the problem. The large sample size, we take the population n times 0.63, and that is a number that is greater than 10, so this condition is met. And then we take n times 1 minus 0.63, and that is a number that's greater than 10, so that parameter is met. The large population says that 10 times the sample size must be representative of the population, and the population of Americans is greater than 10 times 943. In fact, the population of America is between 3 to 400 million right now. Yes? Okay. So that means that the conditions are met. We're not going to use these methods to calculate the test statistics. We're going to use technology to compute the test statistic and the p-value. Okay, and I'm going to show you how to do that very soon. Okay, now when we use the technology, we see that this p-value is very small, so we would reject the null hypothesis. If you reject the null hypothesis, is saying that your support for the death penalty has declined. If you're rejecting the null hypothesis, then you're agreeing with the alternative hypothesis. Let me go ahead and show you how to do this with StatCrunch, okay? So we're told here that we have, here we go, 538 out of 943 Americans supported the death penalty, and we're given 63%. So go ahead and access your StatCrunch. Remember that you can access StatCrunch by just Googling StatCrunch and using your MyMathLab, MyStatLab password and access StatCrunch directly. You do not have to go through StatCrunch, okay? You do not have to go through MyLab. You can go directly to the site and use your Pearson login to check it out. All right, so to do this, you press the Stat button, Proportion Stats, One Sample. Okay, let's do that again. Proportion Stats, One Sample with Summary. One sample with summary. So I'll do that again for you. Stat, Proportion Stat, One Sample with Summary. And this is where you would go ahead and, let me see if I can move this. Uh-oh, what did I do here? Okay. So I need to just go ahead and move this out the way so I can, here we go, use the keypad. So here I'm going to type in 538 and 943. Okay. In the next box, I'm going to type in 943. Then we know that the null hypothesis is 0.63, 63%, so 0.63. And we said that it's less than because we're looking to see if it declines. Okay, so again, number of successes, number of observations, null hypothesis, alternative hypothesis. Okay, compute. And we see this nice little table here that gives us what we want. Why can't I copy this? Okay, Control C. I'm not going to be able to get Control C. Maybe I can just use the snipping tool. Yes. Yeah, let's use the snipping tool. Always convenient. So new, and I'm just going to pick this up here as the snipping tool and put this in our notes so we can see it. So we now are able to use the technology directly to get our answer. Yeah, we've found this exact same number. I'm going to try to move this up here. Yeah. No. Okay, let's see what else we can do here. If I put it on the side and then drag it in, maybe that would work. Let's see. What do you think? Okay, that worked. Okay, so we get exactly the same numbers. So I think one of my numbers was incorrect. Yes, I put in 548 instead of 538. So I'm going to have to redo this one using the correct numbers. Yeah. Let's go ahead and put in the correct numbers into StatCrunch. So I would edit this, and I need this to be what, 543 or 538. Okay, so that's fine. You're allowed to make mistakes, just so long as you know what to do to correct them. All right, here we go. So this number should be closer to the one that they have in the problem. Yep. All right, so now I think I have my numbers correct. I can go ahead and drag this into our notes here, and we see that we have exactly the same numbers. Okay. With the TI-84 calculator, it's a little different. What the heck? So let me show you the TI-84 as well. Okay. To use the TI-84 for this, you would go to Stat, scroll over to Test, Enter. Oops. Stat, Test, and we're selecting number 5, one proportion z-test. Enter. And here you would put in, so the null hypothesis is 0.63. Then you would type in 538 and 943. And we know that we're looking for less than. And enter, calculate. And we should be getting just about the same numbers here. To explain what these numbers mean, so with the calculator, I'm getting the same z-stat, and then this is e to the 5th power. So literally, this is a really small number. The 3 decimal e to the negative 5 power. That means it's a really small number. Okay, 0.0000. All right, other things to consider with StatCrunch is that let's close this for a second so we don't have issues here. If we're looking at figures and we have a balance on the left and the right, but in this case negative 1.6 and positive 1.6, we describe this as a two-tailed p-value for the alternative hypothesis. If we have a case where all of the data is shaded to the left, we describe this as left tail test. And if the data is all clumped up towards the right, greater than, we describe this as right tail test. Okay. Now, here's another example. Suppose a poll of 250 randomly selected voters in a city found 140 of them favored increased funding for public libraries, 140 to 50. Based on this poll, could we conclude that a majority of voters, more than 50%, So the null hypothesis is 0.5, and the alternative is p greater than 0.5. And then they said to use a significance level of 0.01. So here we go. This is the null and this is the alternative. We check to see that the conditions are met. Okay, check to see that the conditions are met, and in most cases they're going to be met. And then we go to the StatCrunch program, get a p-value and a test statistic. Now in this case the p-value is 0.0289. And they're telling us that the significance level should be at 0.01. So 0.0289 is greater than 0.01. So do not reject the null hypothesis. In other words, we're going to agree with the null hypothesis and conclude that the majority of voters support increased public library funding. So we will not reject the null hypothesis. So we can launch right into our problems for this section. And remember, the questions here are from 16. For 8.2, it's number 16 to 26. The homeworks are combined into one, so you'll be able to do 1.1 to 15 after completing 8.1, and 16 to 26 after looking at 8.2. All right, question 16. About 28% of the population in a large region are between ages 40 to 65, according to the country census. However, only 3% of the 250 employees at a company in the region are between ages 40 and 65. Lawyers argue that the company hired people regardless of their age. The distribution of the ages would be the same though they had hired people at random from the surrounding population. Check whether the conditions for using the proportion are met. So the condition first for random sample and independence are met already from the problem. Okay, that's implied in the problem. They talked about random, and they talked, about the distribution would be the same in surrounding areas. These two conditions are met. Next, we need to check the large sample condition. Large sample. So we know that P times must be greater than n times P0 must be greater than 10, which is, in this case, 0.28 times the population, 2,500, must be greater than 10. So I put that into my calculator, 0.28 times 2,500, and I get 700, which is a number that's greater than 10. And then I can take n times 1 minus 0.28. Okay, let's write that out properly. N into 1 minus P0 greater than 10. So this is n into 1 minus 0.28 greater than 10. And I put that into the calculator. This is 2,500. So 2,500 into 1 minus 0.28 gives me 1,800, which is a number that's greater than 10. So the large sample is met also. Now, the fourth condition is the large population. Large population says that must be the population must be greater than 10 times 2,500. And we're talking about the entire population in a large region. So this condition, it means that in this region, there will be at least 25,000 people between the ages of 40 and 60. So we can say, yes, all conditions are satisfied and can be readily assumed. Question 17 is asking, when asked whether marriage is becoming obsolete, 740 out of 2072 randomly selected adults answering a particular survey said yes. We are testing the hypothesis that the population proportion believes that marriage is becoming obsolete is more than, okay? More than, so P is greater than 0.34. White-tailed. If we're picking out the picture, this is the only one that's white-tailed. The tail is on the right-hand side because it's greater than. Now, because the p-value here given, okay, the p-value here is 0.0497, and we're given that the significance is 0.05, so it's less than 0.05, okay, we must reject the null hypothesis. We must reject the null hypothesis. So because the p-value is less than the significance level, we reject the null hypothesis. There is sufficient evidence to conclude that the population proportion is greater than and that's 0.34. Yeah, 0.34. Yeah, greater than 0.34. In other words, because we rejected the null hypothesis, we now believe that there is enough evidence to conclude that the proportion is greater than 0.34. Right? We are agreeing, we're rejecting the null hypothesis, so we're in effect agreeing with the alternative hypothesis. Question 18. So let's read the question here. According to a recent survey, 19% of the adult population suffer from an anxiety disorder. Suppose the test of 300 random college students showed 50 suffered from an anxiety disorder. Complete the parts below. How many out of 300 would you expect to have an anxiety disorder if the 19% is correct? So 19% of 300 is equal to 0.19 times 300, which is equal to 57. So 57 adults would be expected to have an anxiety disorder. Suppose you're testing the hypothesis that the population proportion for the college students suffering from an anxiety is not 0.19. Okay, so remember what we said, P0 is equal to 0.19 and P0 is not 0.19 is the alternative hypothesis. Okay, Because it's not, it's going to be a two-tailed probability. Let us interpret the p-value. So we can see that the p-value here is 0.3029, right? And we know that this is less than the significance level of it's greater than the significance level of 0.05. So what does this mean? What does this mean in terms of the answer? Do we reject the null hypothesis or do not reject the null hypothesis? Question? Come back here. If it's less than, we reject the null hypothesis. Okay. If it's greater than, we do not reject the null hypothesis. So in this case, do not reject the null hypothesis. In other words, if 19% of the population were to suffer from an anxiety disorder, okay, there is a, what is that percentage? 30.29% chance that we will observe a z-score of less than 1.32 or greater than 1.302. Okay, plus or minus. If 19% of the population suffer from anxiety disorder, then there is a 30.9% chance that we will observe a z-score less than 1.302. So that is the surprise level. Okay, all right, moving along. Question 19. Suppose researchers were testing people to see whether the rate of the use of seatbelts has changed from a previous value of 85%. Suppose that in their random sample of 500 people, they see that 439 of this have the seatbelt fastened. Which of the following pictures correctly show the p-value for testing the hypothesis? So first consider that the null hypothesis is p0 is equal to 0.85. Okay. Then when we read this problem, whether the use has changed, okay, has changed. It doesn't say whether it increased or decreasing. In other words, the alternative hypothesis is that P cannot equal. It's changed from 0.85. So this would definitely be a two-tailed hypothesis. So graph, what is that? Graph B is the correct figure because the alternative hypothesis should be two-sided or two-tailed or whatever they call it. The test is to see if the proportion has changed for better or worse. We don't know. We know that they're testing to see if it changed or not. Okay. Question 20. And here they give us a printout of a calculation. According to a reputable magazine, 33% of people in a certain large country have sleepwalked at least once in their lives. Suppose that a random sample of 250 people showed that 55 reported sleepwalking. The null and alternative hypothesis for a test that would test whether the proportion of the people have sleepwalk is 0.33. So here we're given the null hypothesis and the alternative hypothesis. The conditions for such a test are satisfied. Use the technology output to determine the test statistic and p-values. So here we can see the z-stat to 2 decimal places is negative 3.70, and the p-value to 3 decimal places is 0.000, okay, to 3 decimal places. Now, given that the significance is 0.05, okay? All right, so they're asking first if we should reject or do not reject. Now, 0.000 is definitely less than 0.05. Remember, when it's less than, we reject null hypothesis. So reject the null hypothesis. There is sufficient evidence to conclude that the proportion of people who have sleepwalked is not 33%. If you reject the null hypothesis, it's saying that you're accepting the alternative hypothesis. And remember, our alternative hypothesis is that the HAP is equal to, not equal to 0.33, and we're accepting that null hypothesis. All right, moving right along. Question 21. For each of the graphs, indicate whether the shaded area could represent a p-value, explaining why and why not. If yes, state whether the area could represent a p-value for one tail or two tail. So right here we have one tail on the left at -2 and one tail on the right at +2. So the shaded area could be a p-value, so which is answers A or C, for a test with a two-tailed alternative hypothesis. This one is out. That's a one-tailed alternative, since both are of equal size. In this case, in the center, the shaded area is in the center. Cannot be a p-value because it doesn't have tail areas. Okay, cannot be a p-value because it does not include tail areas. Remember, it has to have tail areas before it can have a p-value. Question 22. For each graph, state whether the shaded area could represent a p-value. Same type of question. So this is clearly a p-value that is left-tailed, one-sided, single-tail area. And this one is same answer, but for right-tailed. Which one of the answers? The shaded area could be right-tailed. That one, yeah. Okay. Single-tail area, one-sided. Single-tail area, one-sided. Okay. Both cases are single-tail. Oh boy, we're getting through this really quickly here. All right, here we go. In a poll of 1,000 adults in July 2010, 530 of those polls said that the schools should ban sugary snacks and soft drinks. Do a majority of adults, more than 50%, support a ban on sugary snacks and soft drinks? Perform a hypothesis test using a significance level of 0.05. So first, a null hypothesis. State the null. Note that P is defined as the population proportion who we believe should ban sugary snacks. right? And we're saying here that, where is the percentage? That 50%, the majority, more than 50%, support a ban. So first P would be equal to 0.5 or 50. That's the null hypothesis, and the alternative was, since more than 50% supported, it would be P greater than 50 for the alternative hypothesis. So we're going to go straight to technology to compute this. Okay, this is 530 and 1000. And I'm going to use StatCrunch. You guys, if you want to mess with your calculator, that's fine. But I'm going to go ahead and use the StatCrunch program. Okay, so stat proportion stats, one sample with summary. I'm going to type in my two numbers, 530 and 1000. Then I know that the null hypothesis is 50%, and then we're told that it's more than the majority, more than 50%. Okay, so clearly this is a right-tailed. Let's see. So compute this. Okay, and we're going to put this into our notes. Okay, and by the way, if you want the graph from this, it's not absolutely necessary, but if you want to see the right tail graph, go back to Options, Edit, and P-value plot, and Compute, and then click the right button, and you would see the graph of the right-tailed figure that you're hoping to see. Yeah, but like I said, not absolutely necessary. So we're going to take information from what we computed here. The Z to 2 decimal places is 1.90. Okay, 1.897 rounded to 2 decimal places is 1.90. The p-value to 3 decimal places is 0.029. Be careful rounding. Okay, so 0.029, and we're given that the null, the significance is 0.05. So this is less than 0.05, which means we reject the null hypothesis. Whenever it's less than, we reject. So the percentage of adults who favor, in other words, since we rejected the null hypothesis, we're going to agree with the alternative hypothesis that the percentage of adults who favor banning is significantly more than 50%. One more problem. According to one source, 49% of plane crashes are due to, at least in part, to a pilot error. Suppose that a random sample of 100, 61% are due to pilot error. Okay. Complete parts A and B. Test the hypothesis that the proportion of airplane accident is not 0.49. Okay. So P1 equal to 0.49 and then not equal to 0.49. Assume conditions met. For hypothesis tests. And you can go ahead and check the conditions if you want, 0.49 times 0.49 times 100 should be greater than or equal to 10, and 100 times 1 minus 0.49 should also be greater than or equal to 10. Okay, and then 10 times 100 is the large population. Okay, this is large sample, but we're just going to go ahead and large population condition is met. Okay, and we know that the sample is independent and random. All right. All right, now let's continue. So we want to compute the Z statistic. For this, we're going to again use StatCrunch. So 61 out of 100. Let's go to our StatCrunch program. So we want to clear this. I'm going to start this from scratch again. So stat, proportion stats, one sample with summary. And we're going to go ahead and type in our numbers. So 61. And then the second number is 100.49. And then not equal to 0.49. Okay, so two-tailed. Compute. And here we have it. So we're going to copy this, paste it over to our notes because we're going to use the answers here. Okay. Let's see if I can drag this over here. Yeah, I can drag it. And if just in case you wanted proof that this was two-tailed, you can go ahead and go back to options, edit the options, select p-value plot, compute, and then you can see the graph of the two-tailed plot. Yeah. Some people might want to see that. I don't know. But if that's you, then we can also show that it's a two-tailed plot. Yeah. All right. So the z-stat 2 decimal places is 2.40. Okay, that number right there to 2 decimal place. And then the p-value to 3 decimal places is 0.016. So we're given that the significance is 0.005, so 0.016 is less than 0.005. That means we're going to reject the null hypothesis. Reject, since it's less than. Remember, if it's greater than, do not reject. There is sufficient evidence to conclude that the population portion is not 0.49. Okay? We're agreeing with the alternative hypothesis. Is not, since we rejected the null hypothesis, we're agreeing with the alternative hypothesis. Determine the correct interpretation of the rejection decision. So what does it mean? In terms of the percentage of plane crash due to pilot error, is significantly different from 49 because the p-value is less than the significance level. Okay, because that p-value is less than the significance level and we rejected the null hypothesis, that means that the percentage of plane crashes due to pilot error is significantly different from the 49%. Okay, in other words, we're accepting the null hypothesis. All right, 25 and 26 came from the notes. The symbol in null hypothesis is always what? Equal? Yeah, equal sign. And finally, in hypothesis testing, when should the null hypothesis be rejected? Okay, so we always reject when it's less than the significance level. Right, things you should know already.